Hello, welcome to our technical series on SAP UFI Fiori. In the last video, we have seen the validation part. Today, we are diving into a fundamental pillar of modern SAP development, OData. We will explore its definition, how to create projects, and the technical structure that makes it work. So, what exactly is OData? It stands for the Open Data Protocol. As its core, OData is a REST-based protocol specifically designed for querying and updating data because it is built on a universal technologies like HTTP, XML, and JSON. It is highly interoperable across different platforms. Standardized by OSs, OData allows developers to create RESTful APIs that focus on the business logic rather than spending time on individual endpoint designs. Why has SAP made OData its go-to protocol? There are three main reasons. Fiori integration. OData is the primary communication protocol for SAP Fiori and UFI. Interoperability. It allows you to easily connect your SAP backend with virtually any non-SAP front-end applications. Efficiency. It comes with built-in support for complex operations like filtering, paging, and complex queries right out of the box. You might ask how OData differs from a standard REST API. While standard REST API is flexible, it often lacks a defined metadata structure and requires manual documentation. OData, on the other hand, is strictly defined via metadata, utilizes standard query parameters like filter and stop, and features self-describing endpoints. To understand how this works in a real environment, we have to look at the SAP gateway architecture. This is where OData is positioned within the broader SAP landscape to bridge the gap between backend data and the outside world. The heart of the OData development in the SAP is the SEGW transaction, also known as the SAP Gateway Service Builder. It is the central hub for designing your services. SCGW provides a visual modeling environment where you can define entity types, entity sets, and associations without having to write any initial code. Creating a project follows a clear four-step workflow. That is initialization. You start by creating a project in SCGW with a unique name. Model, you define your entity types and their properties. Generate, you trigger the system to create the necessary runtime artifacts, specifically the MPC and DPC classes. Register, finally you activate the service in the gateway system to make it accessible. These are the four steps. A typical project structure in SAP consists of three main parts, that is the data model, which houses your entity types and associations, service implementation, where you map methods like create, delete, or get entity, runtime artifacts, the generated ABAP classes that handle the underlying logic. Let's look closer at those runtime classes. The MPC or model provider class defines the structure. It tells the system what the data looks like and how it relates. The DPC or data provider class is the engine. This is where you write the actual ABAP code to fetch or modify data from your database table. One of the best features of OData is the powerful query options available to the consumer. That is filter, select, expand, and order by. These are the queries. Filter restrict results based on criteria like finding items where the price is greater than 100. This is the example. Select query used to limit the properties, return to reduce the data payload. Expand query is used to retrieve related entities in a single request. Order by query is used to source the data exactly how you need it. These are the some powerful query options. After generation, your service must be registered using transaction /IW FND /main underscore service. This is the T code for service registration or activation. This process creates a unique ICF node, allowing the service to be consumed via public URL. You can then test your work using the built-in SAP Gateway client. Thanks for watching.